Well, thank you again, Paul, for introducing me and being part of this series. So I'm going to talk about a work that is in progress. It's called Aphrodisiac in the Machine, and it's an environmental science fiction. It takes the form of a multimedia installation with video and a soft robotic sculpture. And it's the story of bioengineered cyborg oysters that plays on the libidinal myth of the oyster as an aphrodisiac. And before I get into the project, I want to give a little context as to how the project came about. Okay, here we go. So last year I was on my sabbatical, and I'm glad I was on my sabbatical last year. And I had a fellowship at Bowdoin College, which is in New Brunswick, Maine. I was the inaugural scholar, artist in residence for their new environmental studies program. And I wanted to show an image of the coastline. For those of you not familiar with New Brunswick, Maine, it's about 2 hours north of Boston. And it's right in the Gulf of Maine. It has about 3,500 miles of coastline, which is actually longer, more than California, which is surprising, and about 3,000 offshore islands. And the Gulf of Maine stretches from Cape Cod to Nova Scotia, and the waters are actually warming faster than 99% of the global ocean. And this is partly due to the fact that it's located between cold water masses of the Arctic and warm water masses that are coming from the Gulf Stream. So this has created a very drastic environmental shift to the ecosystem and also to the economic livelihood. Maine has this very historic fishing industry. Can everyone see my images too? Most notably the lobster and the lobster shacks. And Maine supplies nearly 90% of the nation's lobsters. It's a $500 million industry. But since the waters are getting warmer, it's making it more difficult for the fishermen because the lobsters move further and further out to sea. So for the past almost 50 years, they've been developing shellfish aquaculture. And it's really, developing even faster now. And so what you start to see are oysters, a lot more oysters. Maine's shellfish aquaculture is now producing over 3 million pounds of oysters. And to the right, just in case what you're wondering that's like the Maine oyster chowder, which is basically butter and cream. And if you're not familiar with aquaculture, it's a form of fish farming. It uses these suspension systems that look similar to this, and you can see the oysters are kind of more on the ground. And so, and here you can see where the buoys are, and there's just miles of this all along the coast. And there you can see some of the cages as well. And as I mentioned, there's around 150 farms. So one of the largest hatcheries is Mook. And I got to spend a little bit of time, the upper right corner, that's actually both a lab and the hatchery. And they have been working with the University of Maine, and they are noted for creating the triploid oyster. So it actually has 3 sets of chromosomes, and it enables it to grow faster because it's sterile. And you could also eat it during the summer. So normally you don't want to eat oysters during the R months. And in this image here, you could see the broodstock quarantine room where you have the mature organisms that are used for breeding. And you're looking at an upweller system, which is hydraulic water system. And the oysters, as they're being bred, are fed a really high nutrient microalgae system. And then on the lower right, you can see what is known as the spat. And those are the juvenile seeds, which are grown over the winter and then are sold to the aquaculture farmers, where they start to begin to grow them out outside of the facility, starting kind of more in the late spring. And then they also at Mook just built this very, very large new facility where they can actually do land-based farming. And you see in these giant tanks, and that's looking into one of the tanks. So when there's situations where the water has very high bacteria levels in the Gulf, they could actually protect their stock here in these tanks, and then be able to have some that they could still distribute to aquaculture farmers. And so back at Bowdoin, I had a small lab, and I had this window installation. And it was really fun and interesting for me, especially because I didn't really know anything about marine science. And in one tank, I had invasive green crabs. And those have been coming initially from Italy, and now there's a more aggressive crab that's strangely coming down from Canada. And then I also had the tanks of oysters. And that was interesting because you don't think oysters are going to be that exciting, but it was really, really fascinating to watch their filtration system. And you could see here, this was an experiment that I did. And oysters can filter up to 50 gallons of water per day, like a small little 2-inch oyster, and up to 2.5 gallons of water per hour. And the other thing I found to be really interesting about oysters is their resurgence in terms of creating seawalls. And so the way that they reproduce and grow is by adhering to other shells. The shells are created out of calcium carbonate. And only when the oysters are first embryos and then they become larvae are their shells more vulnerable to ocean acidification. And once they start to mature, they're not as affected. So while their early growth period, when they're in the hatchery, and then they go out to some of the aquaculture farms that are on the coast, they are able to sort of test the water conditions and don't put them as further out until they are at least several months old. And it takes about 2 years for an adult oyster to mature and become sold as edible oysters. And so while I was working on all of this, you know, I started thinking, wow, these oysters are these magical creatures, and what would the future of the oyster behold? And I think the other question that everybody's always thinking of, are oysters really aphrodisiacs? And so I started to look into this, and one of the images that always comes to mind is the famous Botticelli's Birth of Venus, where you see Venus, as in Roman mythology, or Aphrodite in Greek mythology, is this goddess of love and beauty that is born of the sea, right? She's coming out of the sea. In this image, it's not an oyster shell, it's a clam shell, but a similar metaphor. And then also the famous Venetian explorer and seducer Casanova from the 18th century. And he had a large collection of books that were his memoirs. And he claimed to eat 50 oysters every morning for breakfast to enhance his libido. Oops. So I started looking further into this more scientifically. And this one study kept popping up. It just had made all these major online news outlets in 2005. You found it in Wired magazine and the Smithsonian. And it was conducted by a team of students and biology professors at 2 universities in Miami and one in Venice in Italy. And they did conclude that major bivalve mollusks, clams and mussels, as well as oysters, contained high levels of DAspartic acid, which is an endogenous non-essential amino acid. And it has been found to increase the level of sex hormones in rats. But the other thing that's really interesting about it is it's become very, very popular in strength training. And so you see this all the time in all of these advertisements. And you can also find a lot of scientific studies about strength training with DAspartic acid, and coincidentally, one that was also conducted in 2015 at the University of Buffalo in the Department of Physiology and Biophysics, where they looked at healthy young males, and they did conclude that DAspartic acid actually improved muscle, upper and lower body muscle performance. But on this study, they actually didn't see that it increased testosterone. So I started to look into this further, and that DAspartic acid actually does more to the body than just improve testosterone. And it was a very kind of limited perspective, at least in pop culture. And that you find that it also is in a very high concentration in the pineal gland, in the production of not only growth hormones and luteinizing hormones for men, but also for women's hormones in the ovaries. And that it also modulates melatonin synthesis. It's not just about bodybuilding. And so it brought me back to the question of, what does the oyster of the future behold, these magical creatures? And could we think about this myth of aphrodisia as a more sentient experience? And in thinking more about that, I wanted to just point out some of the work by Audre Lorde, a Black feminist writer, and her essay, The Erotic is Power, from the late 1970s, and also Donna Haraway and her notion of multi-species entanglements. And thinking about Lorde's text, she really challenges this idea of desire as the erotic is purely sexualized, and more as this heightened state of sentience, right? This creative force becoming more perceptible, and as of agency and power. And looking at that in conjunction with Haraway's notion of these kind of more interspecies relationships and interactions, her kind of sympoesis. And so thinking about what would this futuristic cyborg network oyster be, I started to work with a 3D animator, and we created these models. And in the story, as I said, it's this environmental science fiction. You have this oyster that is networked, where you can see it here. And then also taking you to the futuristic aquaculture farm. And the idea is that this aphrodisia fluid that's produced by these oysters, that they would be able to produce this very potent fluid that would be piped into municipal public water systems so that humans are ingesting it. And aside from your tap, I also looked at other water dispenser systems, such as if we ever get to go to airports again or to malls, and how that could be redesigned to incorporate this new system, which might look something like this. Or if we think about it in a more collective shared relaxation space, it could look a little like this. So at the point where I'm at now in the project is really looking at the possibility of the oyster's genetics and modifying them, and seeing if we could actually affect the production of DAspartic acid and what that might entail. And I had asked Solon to just speak for a minute or two a little bit further on that, because since we haven't had the chance to get into the lab, I think it would be better at articulating what we're interested in doing. So are you there, Solon?
Unmute myself. Okay. Yeah. Sure. So we haven't done any experiments yet, but we've been thinking about what we might do to boost the levels of D-aspartate or D-aspartic acid in oysters. D-aspartic acid is manufactured from L-aspartic acid routinely in animal bodies. L-aspartic acid is the non-essential amino acid that's frequently a component of proteins. The D-aspartic form of that is less common and is particularly abundant in certain kinds of organisms, especially mollusks. So what we thought we could do is, rather than altering the production of DAspartic acid, we could decrease the destruction of it. It's continually being produced in mollusk bodies with an enzyme called aspartate racemase, which will convert it from L to D form. And we don't know much about how that process is regulated. But there is another enzyme that will destroy DAspartic acid on a regular basis, that if we take that gene out of circulation, we could encourage the accumulation of DAspartic acid. So we're going to target the enzyme that destroys DAspartate. It's the DAspartic oxidase, and we know the gene for that. And we're going to use CRISPR, and I'm sure you've all heard about CRISPR. CRISPR is a gene editing tool that is all the rage these days, but it's a tool for making very precise edits in very specific locations in a genome. And so we're going to use CRISPR essentially to break the DAspartic oxidase gene in oysters so that they can no longer destroy DAspartate, and it should accumulate over time. And there's some precedent for this. This has been done in mice to see what the effects of high levels of DAspartate are. So that's the broad plan. And once we get into the lab, we're going to experiment, I think, Stephanie, with zebra mussels first, because they're local. Zebra mussels are incredibly abundant in the Great Lakes. It's an invasive species. They're easy to get a hold of. They're fairly easy to keep in captivity, and they're probably closely enough related to oysters that we can do some pilot work with them, with their genetics.
Thanks, Olin.
Yeah.
How are you feeling?
Very sentient.
Is it immediate?